So what we talk about today is the graphs of the derivative function. Okay, derivative function. So graphs of the derivative function. So you have original graph and you talk about what the gradient might look like. Okay, what the gradient might look like. First of all, I will go through a really 100 really important definition here, which is called increasing and decreasing functions. Okay, it is such easy like concept, but like students keep forgetting something. Okay, keep forgetting something. Let's just have a think. We have I have no place to write. I will just write here. Okay, so that's from the top. Okay, what I'm going to say is two definitions. Well, I'll use strictly increasing function, and then I have strictly increasing function and derivative is greater than 0. What's the relationship between strictly increasing function and derivative is greater than 0? Okay, I will just use that graph as an example. Okay, I will say that point is -3 on 2, 6, and I will say this point is 3 on 2, -8. Okay, I'll give you the coordinates of those two turning points. Okay, let's go just see a simple graph first. Go to see a simple graph. I'll give you the definition first. Increasing and decreasing function. What is increasing and decreasing function? So a function f(x) is strictly increasing on an interval. If x2 is greater than x1, the y value is greater as well. This is called the increasing function. So if you increase your x, your y is also increasing. This is called strictly increasing function. So for this part of the graph, can you see this graph? It is strictly increasing from -infinity until 2. Include 2. Okay, 2 is the last point. It's include 2. So because have a think, if it's 1.9 and then increase to 2, that y1.9 and y2 is actually increased. So 2 will be included. That's the last point for that increasing part. So strictly increasing means you increase your x, your y will also increase. Okay, then strictly decreasing will be when your x increased, your y actually decreased. That is called a decreasing function. But we don't have decreasing function here. Okay, we don't have decreasing function here. And we have something like strictly says like it must increase. Okay, it must increase. So increasing x, the y value must change, increase. This is called strictly increasing. So if I just say what is an increasing function? If I just say the word increasing, not strictly increasing, what will happen is -infinity to infinity. Everything will call increasing function because the definition for increasing will be x increased, y not decreased. X increased, y not decreased. Well, it can maintain the same level or it can increase. You not necessarily like increase, you can maintain the same level. This is called the increasing function. It's not a strictly increasing. Okay, it is just a normal increasing function. The definition will be when x increase, y does not decrease. Okay, so it's all satisfied. Y never go down. It's just maintain the same on the horizontal line. If I say decreasing, I can say that's +2 to infinity. Because decreasing means when x increase, y does not decrease, does not increase. It can decrease or can maintain the same. It is called decreasing. So if you have a horizontal line, it can be increasing function or it can be decreasing function. It's not increased or not decreased. Okay, not going down or not going up for the y values. Okay, so you don't really need to worry about the increasing and decreasing function. You need to know strictly increasing well. Okay, strictly increasing. You would be tested on which part of the function is strictly increasing. Okay, strictly increasing. And next thing we'll think about is strictly increasing for fx. Just think about this function fx. Which part is strictly increasing? Can you let me know? Just x. What x? Negative 3/2. What's the sign here?
Including.
Everyone include or not include? Why not include? Or why do you think include?
Because if you include it, you increase the turning point workstation.
Well, you can't compare a point itself. It needs to compare with the previous ones. Say from -2 to -1.5. Is that the y value increased? -1.5 to -2. Is that the y value increased? No, y increased. Okay, -1, -2, 1, 2 is here. The y actually from -5 to 6 actually increased. So this will be included. Remember, okay, it's not something like you just need to remember that. That's most of the year 12 lose 1 mark on their paper because they not include this point. For increasing or decreasing function, you must include the turning point. Okay, you must include the turning point. Okay, so also we have another part, union 3L2 to infinity, include as well. If I say there's strictly decreasing function, what you will have is include -3/2 to 3/2. Okay, it can be, the turning point can be included in increasing, can be included in decreasing as well. You will include the turning point in when I say that it's strictly increasing or strictly decreasing. Okay, it must include it. It's not you can or you cannot. You must include the turning point in. So that is a thing. You will definitely be asked in year 12 in your SAC. And then half of my class doing that wrong, even though I emphasize a lot of times. Okay, so that's something you need to pay attention. If I say strictly increasing or strictly decreasing, it must include the turning point as well. Next one, derivative is greater than 0. Okay, it's a comparison between this one and this one. When is the derivative is greater than 0? Okay, derivative is the gradient of the tangent. Okay, which part of the graph do you think the gradient of the tangent will be greater than 0? Not the turning point, definitely not the turning point, because the turning point will give you equals to 0. You want greater than 0. It's positive. So it is the same as the strict increasing function, is that, but not including the endpoints, the turning points. Okay, that's the main difference. Gradient is positive. Yes, I'm not going to include the turning point because that is the gradient equals to 0 part. But when I say strictly increasing, you will include the turning point in because that's the point. You still like increase, still compared to 1.9 and 2, it's still increasing. Okay, still going up, so you must include that point in. Okay, next thing I want to say is a little bit confusing. Okay, it's this line here. Okay, the warning line here. I'll just write this down for you. If f dash x is greater than 0, for x belongs to, let's say, a to b, then from a to b must be increasing function. Or strictly increasing function. So if you know that from A to B, the gradient function is greater than 0 already, then you definitely know that part of the graph is strictly increasing function. Okay, that part must be strictly increasing. No, not generally. Generally, like that's a general idea. Because that's x squared is an example. I'll show you this example later. If tell you fx is strictly increasing for x belongs to, like say, C to D, it does not give you f dash x greater than 0 for x belongs to C to D. Okay, that's the two things I'm talking about. So if you know f dash x is greater than 0 for one x to another x, then from that x to that x definitely is an increasing function, strictly increasing function. But if you know from one x to another x is strictly increasing function, it doesn't tell you all the points gives you gradient greater than 0. It can equals to 0. Okay, it can equals to 0. If I say it's greater or equals to 0, that's correct. But I can't say that's definitely greater than 0. Because let's just have a look for x cubed. X cubed. Okay. This is x cubed. Can you tell me, okay, do you know that this point the gradient will be 0? Like it's the point of inflection, stationary point of inflection. The gradient will be a horizontal line. Okay, the tangent will be a horizontal line. So gradient is 0 at that point. But tell me from where to where the graph is strictly increasing. How about the other part? It's all together. It's just keep increasing. Okay, if your x increase, your y just increase. Doesn't matter whether there's a stationary point. Think about, look from the left to right. It's just like going up. There's nowhere to with a horizontal line. So if you sub 1x, if your x increase, your y will definitely increase. If you substitute a larger x value compared to previous value, you definitely get a greater values. So it is strictly increasing for x belongs to R. But f dash x greater than 0 for R except 0. Because the 0 point doesn't give you gradient greater than 0. It's equals to 0. F dash 0 equals to 0. Right? So that's the line I write. If you know the function is strictly increasing, not doesn't mean all the x give you a positive gradient. Some of them can be 0 gradient. So for example, this one, the 0 point is a 0 gradient. But all the rest will be greater than 0. But if you know all the rest is greater than 0, all of this part is increasing function. That's no problem. Okay, it can go one way but can't go back the other. F dash x greater than 0. F dash x greater than 0, and then strictly increasing. Okay, here to here, yes. Going back, no. Okay, it can go one way, can't go back the other way. If it's greater than 0, yes, it definitely is a strictly increasing function. But strictly increasing function doesn't tell you that all the f dash x is greater than 0. Some of them can be 0. Okay, some of them can be just 0. Example is that one, is the cubic one. Alright, if now you see the shape of the graph, you will tell what is the gradient will be. Okay, positive or negative. You can tell whether the gradient is positive or negative. Okay, let's have a look at well, I used the space already. Well, it doesn't matter. Well, let's say that's negative 3 over 2 comma 6. Yep. Well, I'm not going to use that one. I will use another one. I have plenty of them. Okay, let's just have a look at this one. D is exactly the same as the above one. Well, this is not fx, it's f dash x, or say dy dx. That's dy dx. This next one is dy dx, the y-axis. I'm trying to sketch the gradient function. Okay, I tell you there's a local maximum at -1 and 7/6, and I have a local minimum at 2 and -10/3. So if you want to sketch the derivative function, first of all, you will think, what's this graph looks like? What kind of graph is that? Is that quadratic or cubic, right? It's like a cubic. So what's the derivative will be? It's 1 power down, right? Remember, you put the power in the front and reduce the power by 1. Quadratic. That's to the power of 3. You reduce by 1 is power of 2. Therefore, you will have a quadratic graph. Okay, you know what kind of graph you have. You have a quadratic graph. Second, what you're looking for first, well, the first thing you think about, what kind of graph is that? And then reduce the power by 1 and what the graph looks like. So you know that it's quadratic. Second, you're looking for stationary points. You know it's maximum turning point or minimum turning point, or it can be the point of inflection. Those three kind of points will give you gradient equals to 0, because the tangent is just a horizontal line. So let's have a think. What is the turning point? Now, what is the f dash x equals to 0? Where f dash x will be 0? X equals to what? Your f dash x will be 0. -1 and 2. Okay, I'll label -1 and 2 at this point. Okay, you will have on the gradient function is -1, 0 and 2, 0. Alright, you can have two ways, like that's the turning point, right? It's a quadratic and this is a turning point. You have two ways to sketch it. It can look like this. It can look like that. Or it can look like that. Okay? You will decide which one you want to do. You decide. Okay, let's look at the middle. Let's look at from -1 to 2. Is that increasing or decreasing function? Decreasing function. Decreasing function give you gradient what? Positive or negative? Negative. It must be decreasing, negative. So, this, in between this, the graph must be below. Okay, the graph must be below. So, the shape of the graph must be this. Otherwise, the other way you sketch it is above. Okay, it's above if you turn that way. And this is not like exactly the graph because you don't know the dilation. I can just stretch longer, stretch lower, like this way, that way. You just need to maintain the 2x intercept and the shape correct. That's all good. Okay, you just need to know the shape and the x-intercept. You don't need to worry about the y-intercept. You don't need to worry about the turning point. What you need to know is the x-intercept and the shape of the graph. Well, whether it's upwards, upright quadratic or it's a inverted quadratic. That's what all you need to show. Okay. Well, this shape is so ugly. I was like, I will change it next year. Make the scale a little bit larger, so that will look better. This year, just looks like that. Okay, go back to this page, the table. Okay, this table. So this table tells you what you need to looking for. If the graph is fx, if you get a positive gradient, so you will sketch that above the x-axis. You will have a positive gradient. Your f dash x will be greater than 0. So that means your f dash x is greater than 0. Therefore, you will sketch above the fx. If it's a negative gradient, your f dash x will definitely less than 0, and you will sketch below the x-axis. Okay, below the x-axis. If it's a turning point, it is the x-intercept. If it's the stationary point of inflection, it will be the x-intercept as well. But like I'll talk about more about the point of inflection thing. Okay, let's go to sketch it. Well, actually, all of this graph is dy dx. Okay, the y-axis dy dx. I haven't changed it. That's all dy dx. Okay, What's the gradient function will look like for the first one? Okay, the first one is y equals to what? 3. Okay, what's the gradient for y equals to 3? 0. So it's y equals to 0. dy dx equals to 0. Okay, you need to sketch it. It's just a horizontal line. Y equals to 0. Well, it's not y, it's dy dx. dy dx equals to 0. Okay, for the next one, what do you have? Well, it's increasing. What kind of graph is that? Linear. What's the derivative for linear will be? Yeah, constant. So it will be a horizontal line as well. But what is the gradient for that linear? Don't tell me you don't know how to find the gradient of the linear. I will be scared. Year 11 already, no. So y2 minus y1 over x2 minus x1, it is 2, okay? 2. It is 2, right? So you sketch y equals to 2. Okay, that's dy dx is 2. So you have 0, 2 here. Okay, the gradient can be found by 0 minus 1 over minus half minus 0. And that is minus 1 divided by negative half, and it is 2. Okay, so it's 0, 2. Okay, next one. What graph is that? Quadratic. Do you have what the derivative looks like? Linear. Okay, linear. First, let's find x-intercept. Where is the x-intercept? 2, right? 2. Turning point. 2. Well, you will have 2 types of linear. One type looks like this, while the other type looks like that. You need to decide. Increasing linear or decreasing linear. So let's have a think. Let's look at the right hand side of the 2. Is that increasing or decreasing? Right hand side of 2. Increasing. So on the right hand side, the graph should be here. How about on the left hand side? Decreasing. On the left hand side, the graph will be here. Then you must have a graph looks like this, right? Above the x-axis and below the x-axis. So the graph must look like that. It can't be the other way. It can't be the other way. Well, it can rotate a little bit. You don't know the exact gradient of it, but like you need to show that's an increasing linear. And the x-intercept is at 2, 0. That's it. That's all what you need to show for the derivative function. Where's my... Okay, next one. Next one. Okay, what is this graph? This one. E. What is called? Cubic? Okay, if it's a cubic, what's the derivative looks like? Quadratic. Okay, let's have a look. Where is the x-intercept? 1, right? The point, stationary point of inflection is here. So 1, 0 must be the intercept. Okay, what's the quadratic will looks like? Well, if you can't see it, let's have a think. On the right hand side of 1, is that the function is increasing or decreasing? Increasing. So graph here. On the left hand side, is the graph increasing or decreasing? Increasing, right? It's on top as well. So you have a quadratic, both of the things on top. Then you must have I can't go to the turning point. Oh, here. That's the turning point, 1, 0. And it's all above. Okay, all above. Why my quadratic looks so bad? Well, you need to sketch it looks like symmetrical, but mine is not really. But I don't care. Just looks like that. Okay, next one. Well, I can't tell what is, like, I think it's a quartic. Okay, I think this one is a quartic. You have a stationary point of inflection here, that's to the power of 3, and you have a turning point, that's to the power of 1. So I think it's a quartic, you have a cubic. Well, it's a polynomial, you know that's a polynomial. So where is the turning point? You don't have 0. It's -1 and 1. Okay, -1, 0 and 1, 0. So -1, 0 and 1, 0 is here. Okay, what you need to decide is first, on the right hand side, okay, your x-axis has been separated into 3 parts. That's what you need to think. Okay, let's draw a wall here. Okay, it's actually 3 parts of the graph. Okay, on the right hand side of 1, on your original one is this part. That's an increasing graph. Okay, so you will have graph on top here. In between -1 to 1, that's an increasing graph as well. So you have graph here as well. And the last part is to the left of -1, that is decreasing. So you will have graph here then. And you need to pass through those 2 x-intercepts. Your graph will definitely look like, well, my sketching is kind of weird, but well, something like that. Well, in between -1 to infinity, you must have all the part of the graph greater than 0, above, and then only to the left of -1, below. Okay, only to the left of 1 is below. So 1, 0 and -1, 0. Okay, that's how you sketch about the gradient function. Okay, that's how you sketch the gradient function. Okay, dy dx. That is very important skill. Okay, that is very important skill. I will use it backwards later when I look at the gradient function and I want to sketch back for the original one. I will do that as well later. So it is a very, very important skill. Okay. Okay, next one. Consider the coordinates of the points on the curve with the equation y equals to x squared minus 7x plus 8, at which the tangent line makes an angle of 45 degrees with the positive direction of x-axis. I want to find that which point the gradient will give me 45-degree angle. Okay, let's have a think. What angle of 45 degrees gives you? What that actually tells you? So I'll say I have a quadratic. Shh. I feel hard to talk now. Okay, I have a quadratic. And I say there's a tangent somewhere. I don't know where is it. I will say somewhere. Let's say here. Okay, that point got a tangent with a 45-degree angle with the x-axis. What's that 45 tells you? Tangent theta tells me what? For linear, tangent theta tells me what? The gradient. Okay, m equals to tangent theta. Okay, the gradient of the linear is the tangent of the angle that the linear make with the positive x-axis. Okay, make with the positive x-axis. So, well, tangent theta and tangent 45 is what? Tangent 45, everyone? Tangent 45, 1. Okay, so I know that the gradient of this linear is 1. Okay, what is gradient of the linear? Not m, use another symbol to represent. Gradient of linear, gradient of something is what? The gradient of the tangent, what is it? dy dx, okay? That tells us dy dx is 1. Okay, if the tangent's gradient is 45 degrees angle with the horizontal, then tangent 45 is 1 is the linear's gradient. So the linear's gradient, it is also the gradient of the tangent, which is dy dx equals to 1. So you just look for dy dx equals to 1. Then A is dy dx equals to 2x minus 7, and you want that equals to 1. So x gives me 4. X gives me 4. So y equals to 4 squared minus 7 times 4 plus 8. That's y equals to 16 minus 20. Y is minus 4. So 4 minus 4. Okay, 4 minus 4. So the coordinates is 4 minus 4. At 4, x equals to 4, if you sketch a tangent line, then that tangent line will make a 45-degree angle with the horizontal. For B, says it's parallel to the line y equals to negative 2x plus 6. Okay, the gradient is parallel to that line. Let's say we have this line here. Okay, that's minus y equals to minus 2x plus 6. I want a tangent line which is parallel to that. Okay, I want a tangent line which is parallel to that. Okay, parallel to that, and it's also the tangent for the graph. I think it's approximately here. Okay. So what's the gradient of this black line? Okay, y equals to negative 2x plus something. Okay, I don't care what is it. So then the dy dx is negative 2. Okay, the dy dx is negative 2. Okay, and I will just say 2x minus 7 equals to minus 2. 2x equals to 5. X equals to 5 over 2. So 5 over 2 squared minus 7 times 5 over 2 and plus 8. 25 over 4 minus 35, 70 over 4 plus 4 on 32. 57. Minus 30 over 4. Yep. So 5 over 2 minus 30 over 4. Okay, so that's the coordinates. Okay, that's the coordinates. Let's have a look at example 3. Okay, the planned path for a flying saucer leaving a planet is defined by the equation. Okay, so for that quotic and for x greater than 0. Okay, first of all, can you help me to sketch this quotic for the correct domain? Just sketch that quotic for me. Y equals 2 a quarter x to the power 4 plus 2 over 3x to the power 3. Okay, can you just sketch that for me? How do you sketch that? Did you have something like that? Well, the full graph will look like this. Okay, you need to know the full shape of the graph, but like on the right hand side, it's only an increasing function. So I will just factorize it. You can take x to the power of 3 out. You will left like a quarter x plus 2 on 3, and then you solve for x. You have negative 8 on 3, which is the negative x-intercept. And you also have 3 intercept at 0, 0, 0. Okay. So it's become a stationary point of inflection at that point. So it's like the shape like that. Okay. So let's have a look. Find the direction of the motion for, like, this is the path. Okay, this is the path. Well, if you learn physics, you know like all the motion is tangent to its path. Okay, everything's motion is tangent to its path. Well, how like every single time is facing a different direction, right? Every single time is facing a different direction. So at that instant is facing the direction is the tangent to the path. Okay, it's the tangent to the path. So I'm looking for the direction of the motion when x equals to 2. So let's just draw x equals to 2. That's x equals to 2. And that is the where it is, and the tangent is like that. Okay, the tangent is like that. So the flying saucer is actually towards that way. Okay, at that second is flying towards that way. It's always the tangent to the path is the motion at that instant for something. Okay. So now it's like the reverse way of the previous question. What I'm looking for is the angle make with horizontal. Like if you talk about the direction of motion, how you can describe it? You describe it like how many degrees it makes the angle with the horizontal and then traveled. So first of all, I need to find the gradient of the tangent for that line if I want to look for that theta. Okay, if I'm looking for that theta. So I want to find dy dx. That equals to x cubed plus 2x squared. And then when x equals to 2, dy dx equals to 8 plus 8, which is 16. So this line is y equals to 16x plus c. I don't know what exactly that line is. Well, I can find it out. I'll tell you how to do that later, next chapter. But what I know now is the gradient of the linear is 16. Okay, the gradient of the linear is 16. So what then I will know is tangent theta equals to 16. Because that equals to m. So m also equals to tangent theta. Then theta is tangent inverse of 16. Tangent inverse of 16. So what is tangent inverse? Tangent inverse of 16. What I will have is the radius form, because my calculator is in radius, and I will divide 180 over pi. Y 180 over pi, change that radius to degree. I have 86.4236656 degrees. Well, leave two decimals, 86.42. Okay, it makes with the horizontal of the angle of 86.42 degrees is flying towards that way at that second. Okay, at that second. Okay, that's AI. So AII is like x equals to 3. So same as that. dy dx is x cubed plus 2x squared. When x equals to 3, dy dx will be, well, 3. 3 times 3 times 3 is 27, plus 3 times 3 is 9, 9 times 2 is 18. Okay, so that's a 45. It's not 45 degree, okay? It's not 45 degree. It's the line with a gradient of 45. Okay, the line with a gradient of 45. Therefore, tangent, well, let's use another angle. Tangent beta, are you alright? Okay, don't talk. We have beta is tangent inverse 45. Again, same way we're trying to find it. Tangent inverse of 45, and that will gives me the radius, and I will just go outside to cough. She's so nice. Don't want to get recorded. Times 1. Oh my god, I hate without keyboard. 180 over pi. Okay. That's 88.73. 88.73. Okay. It's like, you know, like it's going up. It's going up. So the tangent will keep going up and up. Okay, so I'm flying that way. So I need to continuously going up. Okay, so it's 88.72 degrees. 72 or 73? 73. Okay, so that is like the flying path. Okay, the motion of direction is 88.3 degrees make with the horizontal. Okay, it's flying that way. Questions? Okay, B is find a point on the flying saucer's path where the path is inclined 45 degrees to the positive x-axis. So that is the same. So that is dy dx equals to tangent 45 degrees, and that equals to 1. Okay, that equals to 1. So what you're trying to solve is x cubed plus 2x squared that equals to 1. That's x cubed plus 2x squared minus 1 equals to 0. How do we solve for that? Don't tell me you don't know that. Okay. How do we solve a polynomial equals to 0? X should be -1. Then I will use my table thing. I have 1, 2, 0, -1. I will try -1. It is 1. -1 plus 2 is 1. -1 plus 0 is -1. -1 is 1. 1 plus -1, which is 0. Great, we have it. So that is x plus 1, x squared plus x minus 1 equals to 0. So it's either the linear equals to 0 or the quadratic equals to 0. So linear equals to 0, or, well, I don't want to factorize the quadratic. I can't simply factorize it. I just solve for it. So first one is x equals to -1. For this one, x equals to -1 plus minus square root b squared minus 4ac over 2a. And that is -1 plus minus root 5 over 2. 3 values. Okay, I solved that as 3 values. But can I take all of that? I will let you finish first. And then you think about my question. Can I take all of these solutions? Or if you say no, which one you can take? Which is the positive one? There's a minus as well. The plus root 5 over 2. Okay, root 5 over 2 is 2 point something. Okay, 2 point something. So 2 point something minus 1 is 1 point something, divided by 2 is 0.6 something. But you can't take the minus, you can't take the minus 1. So you say because x is greater than 0, so x equals to -1 plus root 5 over 2. Have we learned probabilities this year yet? Yes. We did, right? Yeah. Yeah, the easy part of the probability, yes, we did it. No, not 199 maybe. Okay, C is asking, are there any other points on the path which satisfy the situation described in part B? No, it's not. Because it's 3 values, but those 3 are 2 negative, so only 1 satisfied. And the motions keep going up. You won't like going back to 45 degree again. So it's every very low x, you have a 45, and then it's keep increasing, and you're going up that way. Okay, so there's no. C answer is no. Okay, no. Yes? Okay, yes. Any other questions? No? Okay, then we finished.